Welcome to The Explainer. Today, we are diving into a topic that literally surrounds us every single minute of every single day. Yet, its hidden impact is something most of us completely overlook. We're talking about the spaces we live in, the spaces we work in, and the sheer environmental weight of our built environment. We often picture heavy industry or gas-guzzling cars when we think about global resources and emissions. But today, we're going to completely reframe that perspective. 50%. I just want you to pause and let that number sink in for a second. Around half of the global electricity demand today comes directly from the building sector. Half. In fact, over 50% of the new growth in electricity demand since the year 2000 has been driven entirely by buildings. Every time we flick a switch, turn up the AC, or power up our appliances, we are tapping into a system where buildings are the absolute undisputed heavyweights of energy consumption. And honestly, as average global temperatures keep rising, this demand for cooling is only going to skyrocket. So let's unpack this in Section 1, the Global Building Challenge. Look at the sheer volume we are dealing with here. 9 billion tons of CO2 equivalent are emitted annually by the building sector. That is roughly 18 to 19% of all global emissions today. And here is the truly alarming part. Under high-growth scenarios, emissions from buildings are projected to double by 2030, with almost all of that growth coming from the developing world. When we talk about tackling climate change, we literally cannot make a dent without radically rethinking our buildings. But hey, the impact isn't just about carbon and energy. The building sector also gobbles up a massive 25% of the world's fresh water. We are talking about a planet where more than a third of the population is already dealing with water scarcity. By 2025, 1.8 billion people will be living in regions with absolute water scarcity. So, over-extracting water for building materials, plus the inefficient use of water within the buildings themselves, it's a critical concern. Which brings us to Section 2, the coming building boom. Get this, 35 billion square meters of floor space will be built in just the coming years. Developing countries are facing this perfect storm of massive population migration from rural areas into cities, combined with general population growth and rising living standards. People need housing, right? They need businesses, they need infrastructure. To put this massive scale into perspective, the entire built environment of our planet is expected to double by the year 2050. The urgency here is off the charts. We're pouring concrete and raising steel at a completely unprecedented rate. And this building boom is highly concentrated in middle-income countries. Just look at the volume expected in China, projected to build over than 10 billion square meters. India is going to build nearly 2 billion. Brazil is nearing 1 billion, and Mexico is over 500 million. The future of our global climate, and really our resource availability, is essentially being decided right now in the blueprints of these emerging market cities. So how do we fix it? Let's get into Section 3, defining green buildings. The World Bank actually offers a highly pragmatic and quantifiable definition here. A green building isn't just, a building with some nice ferns in the lobby. It's a building that achieves a measurable 20% reduction in energy use, water use, and the embodied energy in its materials, compared to an equivalent local benchmark. It's totally relative to local climate and construction practices, meaning a green building in Norway is obviously going to look very different than a green building in Nigeria. But that strict 20% efficiency standard, that remains a unifying goal. Now, if we break down the energy impact of a typical office building over a 25-year lifespan, you'll see a massive 87% slice is operational energy. That's your everyday cooling, the lighting, the fans, the pumps. But whatever you do, don't ignore that 13% slice. That is embodied energy. It's the hidden footprint of the raw materials, the manufacturing of the steel and cement, and the actual construction process itself. To truly build green, designers absolutely must tackle both the daily operations and the literal building blocks used to construct the space. Okay, moving on to Section 4, the green business case. The commercial realities here are pretty undeniable. Let's bust the myth right now that sustainable architecture is just expensive charity. Green buildings are economically more attractive across the board. For builders and developers, they command higher sales prices and boast much quicker sales cycles. We're talking sometimes selling up to 4 times faster. For banks, you see lower loan default rates because buyers aren't being squeezed so hard by operating costs. And for the buyers and tenants, well, they get the massive benefit of significantly lower utility bills and higher resale values down the line. Everyone in the financial ecosystem gains a serious advantage. It's simply better business. Let's look at how this plays out in the real world. Section 5, sector-by-sector opportunities. Let's compare two very different beasts. For commercial offices, tenant demand is what drives the market. The high-impact interventions here are all about maximizing passive cooling, optimizing daylighting, and using low-energy lighting to slash those operational costs while keeping the workers comfortable. But contrast that with healthcare facilities. Hospitals absolutely cannot compromise on patient outcomes. Their priorities shift heavily to strict hygiene, highly controlled variable frequency ventilation, and really clever systems like heat recovery and absorption chillers. The 20% efficiency goal is exactly the same, but the engineering pathway to get there is completely customized to the sector. And what about where we shop? In retail and supermarkets, store owners are never going to compromise on product placement or the lighting that makes their goods look appealing, right? But they can still make massive cuts to their footprint. Supermarkets can install highly efficient refrigeration equipment that uses low global warming potential refrigerants. Malls can utilize smart daylighting and displacement ventilation. They can drastically cut their utility overhead without the customer ever noticing a drop in the retail experience. It's a total win-win. Now, for the hotel and residential sectors, there's this huge opportunity to align really beautiful architecture with resource efficiency. Especially with the massive rise of ecotourism, utilizing local natural resources and smart, localized passive design, things like deep shading and optimal sun orientation, can provide an incredibly attractive guest experience. Plus, it naturally resists the heat, which dramatically lowers the need for artificial cooling and imported high-embodied energy materials. Which takes us to the absolute core of all this. Section 6, the efficiency principle. Let's step through this crucial hierarchy, because this is the golden rule. Step 1, you absolutely must always start by reducing demand through good, passive architectural design. Orient the building correctly, use sheeting, use natural ventilation. Then, step 2, once demand is as low as physically possible, you meet the remaining need with highly efficient building services and HVAC systems. Moving to steps 3 and 4, then, and only then, do you look to offset that energy use with decentralized on-site renewables, like solar panels, followed by off-site renewables. And finally, step 5, conventional energy sources, the grid, fossil fuels, gas. These must be the absolute last resort. Listen, you don't just slap a solar panel on a poorly designed glass box. You design the box so it barely needs the solar panel in the first place. All of this leads us to a highly practical challenge. What green ideas will actually work for your specific project? And what are they going to cost? Every new development, every renovation, it's a fresh puzzle. But you now have the framework to look at upcoming projects, assess the local climate, and run the numbers to find that 20% efficiency sweet spot. We have a massive but narrowing window of opportunity right now. With 35 billion square meters of floor space about to be built, the decisions being made today are going to shape our skylines, our economies, and our planet's climate for generations. So the real question we have to ask ourselves is this: will we build the future based on the habits of the past, or will we choose to design for a sustainable tomorrow?